Okay, but before we do the basics, we need to understand the notation. Okay, so for notation wise, okay, we will usually use this symbol d over dx, right? So this actually means that it is differentiate with respect to x. Okay. Later on, when we cover the skill, this might be more understandable, okay, over what this actually means. Okay. It is not a fraction; it is a notation. Okay. It is just written somewhat like a fraction. Okay. You cannot cancel the d like that. All right. Then becomes 1 over x. No. All right. It is not an algebraic fraction at all. Okay. It is just like an operation. Okay. See it as somewhat of operation. Okay, so this means that differentiate with respect to x. Okay, why is it with respect to x? Because there's an x below. So if we were to write maybe d over d y, right, this would mean that it is with respect to y. Okay, so later on when we cover the skill itself, you might understand this term better. Okay, instead of writing d over dx, sometimes, okay, if we were to maybe say that we have some algebraic expression, okay, some function fx maybe equals to x squared plus a. Okay, for example, something like that. If I want to differentiate this function, sometimes I could actually arrive at this notation whereby I have this prime on top, okay, f prime x. Okay, so this is like the first derivative, right? Okay, so this will also replace the meaning of d over dx. Okay, and so this is also the same meaning. Differentiate okay. So these are some notations that we will be using for this chapter and the next few chapters. Okay, first rule that we will use will be the power rule. Okay, so for instance, if I have equation y equals to x to the power of n, okay, and then I want to differentiate this, okay, so differentiating it wise, in terms of differentiating it, you write dy over dx, okay, so we are differentiating y with respect to x, okay, so the y actually is in the so-called numerator, okay, dy over dx will be equals to, you bring down the n, okay, n times x, then the power n minus 1. Okay, so that is how we use the power rule. Bring down power minus, then after minus 1 for the power. So for instance, if we have y equals to x to the power of 20, then dy over dx will be equals to 20x to the power of 19. Okay. Differentiation. Okay. Then after that, if I want to differentiate, in this case, y is equals to 1 over x to the power of 40. Okay, our rule is that we have y equals to x to the power of n only. It is not 1 over something. But our indices laws that we are familiar with from last year, okay, will tell us that y equals to 1 over x to the power of 40 is the same as x to the power of negative 40. Right? Okay, so therefore, applying the power rule, okay, it will become negative 40, bring down the power, x, then negative 40 minus 1, so that will become negative 41. Okay? So you could leave your answer in this manner, or as per common practice in our usual indices, we leave our answers in positive index form. So if we leave it in positive index form, this would be the answer. Negative 40 over x to the power of 41. questions up to here? Yeah. Either of these is fine. Okay, unless the question specifies that it must be positive index form, then please leave it in this manner. Okay. What does differentiation mean? It is the process of doing this. Yeah. Sorry? Why? So if, for example, right, okay, if I want to differentiate, okay, instead of maybe instead of writing y equals to x power 20, okay, maybe if the question were to say fx equals to x power 20, okay, then please we do not write this, okay, we don't usually write this dfx over dx, okay, an alternative that we write will be f prime x, okay, equals to 20x to the power 19. Okay? Yes, as in the prime line, yeah. The apostrophe kind of thing. Sorry? Okay, if the question gives you fx equals to x power 20, then you should not be writing dy over dx anymore because there's no y being defined. Okay, if they give you fx, then you should use f prime x. Okay? Understand? Any questions? Why do we differentiate? What is it for? Okay, later on when we look into some applications, alright, you will better understand the whole idea of differentiation. Okay, some parts of differentiation being used will be maybe to find gradient. Okay, which will be looking into it in maybe about 1, 2, 3, 4, 4 questions time. Okay.
Time by lessons.
Okay, any questions for that? The power rule? Okay, another rule that we will commonly use, it will be the constant multiple rule. Okay, honestly these are all just names given to the rules. I don't remember the exact names. So if you were to send me a WhatsApp and ask me power rule, right, I might need to go back and flip the textbook. Okay, so I don't usually use these terms. Okay, these are just titles that you find in the textbook. Yeah. When do we use this? If the function, the question define it as fx equals to x power 20, then you will use this. Yeah, instead of using this one. Because the question used y, so we use dy over dx. Okay. So the constant multiple rule is that, okay, if fx, okay, there's a function, right, and k is a constant, okay, then in this case, then if we were to differentiate, okay, k fx. So for example, there is some function, maybe x squared, okay, kx squared, right? So this is how you interpret this. Okay, so sometimes we actually write it in this manner as well, right? We'll actually be keeping the constant, and then you differentiate the fx. Okay, this is the theorem itself, right? To understand the application, okay, let me show you one example. Okay, so for example, if the function given is that 8x to the power of negative 5, so 8 is like the k over here. Okay, if I want to differentiate this, I will keep the 8. Okay, I just have to bring down the power negative 5. Okay, then x to the power of negative 6, because negative 5 minus 1. Right, then I simplify this will be negative 40x to the power of negative 6. So what this is trying to say is that you just keep the constant if it is being multiplied by a function itself. Do you understand me so far? Okay, so if give you another example, if I have 20x to the power of negative, okay, maybe don't use negative, power of 7. Okay, so if I give you a function like that, and dy over dx will be 20 times 7 times x to the power of 6, and that will give you 140 x to the power of 6. Okay? Then in part B for try 2, if you have y equals to 2/3, then square root x to the power of 3. Okay, so always simplify using your indices law first. So this refers to 2/3 times x to the power of what? 3/2. Okay, so dy over dx will be 2/3 times 3/2 times x to the power of 3/2 minus 1. Okay, I'm just writing it clearly over here. If you can calculate fast enough, of course you don't need to show that one. So in this case, this will be x to the power of half. You can write it in this, or you can write it as square root x. Right? Either one is fine. Yep. Oh, sorry. Yeah. Okay, any questions? Okay, looking at try 3, if I want to differentiate y equals to 1.001x, okay, so dy over dx, what would it be? What will your answer be? 1.001. Okay, because this is a power of 1, so you times 1. I mean, if I were to write it clearly, okay, I multiply by the 1x, 1 minus 1. Okay, that's why my answer is 1.001. Okay, of course, progressively you will get fast enough. Alright, you need not actually write this. Okay. Then after that, part B, if y is equals to 9,999 times square root 3, okay, there is no x over here, then how do we differentiate with respect to x? Okay, we know that this actually is like a multiplying of 1. Alright, so 9,999 square root 3, okay, I can multiply by 1. 1 is also equivalent to x to the power of 0. Agree? Okay, so if I want to differentiate this, the rule can still apply. Alright, it will be 9999 square root 3 times 0 times x to the power of 0 minus 1. Correct? But anything times 0, that will give you 0, right? So what this is telling us is that if I have a constant, okay, if y is a constant, okay, constant k, then dy over dx will be equals to 0. So any constant, when you differentiate it, it will be a 0 for its derivative. Any questions? So regardless of whether y is equals to 1,000,000,999, 0.001, okay, as long as it is a constant number, the derivative will actually be equals to 0. we have covered up to try 3, right, we notice that the functions that we are discussing is always just one term. Okay, it is just 1.001x. Okay, there is no plus x squared, okay, plus something else or minus something. Okay, so in this case, how do we actually do if there is a whole function, okay, whereby there are multiple terms inside it? So we will look at the sum rule and difference rule. Okay, basically you just differentiate by each term. Okay, the general idea is really just to differentiate by each term. So formally, if I were to write it down, so if I have to differentiate a function, say u plus v, so u and v are in terms of x, okay, I will differentiate u, then after that also differentiate v. Okay, so u and v are terms, okay, that are in terms of x. Okay. So that we can differentiate with respect to x. Right? So even if it is a minus, this rule will apply as well. So example, if I have to differentiate y equals to x squared plus 3 over x, okay, how I will do this will be differentiating dy over dx